All right, so welcome back to the second part of lesson 2. So what our final stretch here is dealing with fractions, decimal, percent. So you should be able to convert decimals to fractions for me. And let's talk about the how. So we'll do the 3 versions here. So let's go 0.3, 0.03, 0.003, and so on and so forth. You'll see the pattern after. So remember that in the decimal world here, it goes tenths. Oh, I ran myself out of space here at the top. So 0 decimal. So we have tenths, hundredths, thousandths, and so on and so forth. Well, wherever our decimal or numeric value is, that kind of dictates what the denominator has to be. So we have 0.3. We only have 1 digit, and it's sitting in the tenths column. So that means to make it into a fraction, we write the number with no decimal over the column it was sitting in. So it was in the tenths column, so this number is 3/10. The last number, okay, the 3, is sitting in the hundredths column, so that means it would be 3 over 100 to get it as a fraction. And the last one, it's sitting in the thousandths column, so it would have to be 3 1,000ths. Okay, so it's wherever that last digit is sitting. So you could have digits leading up to it. So I'll just do one more brief example on the outside here. Let's say we have 1.2005. So where is that last digit sitting? Tenths, hundredths, thousandths, 10,000ths. So the 5 dictates what's going to be in the denominator. You write the top number, 12,005, and you put it over 10,000. Okay, so that last digit, whatever placeholder it's sitting in, that is your denominator. So if it's in the 10,000ths, it's in the 10,000ths column. Okay, just that simple. Converting percent to fractions. So if we have, say, 35% and say 75%, how do we do that? Simply put the percent over 100, because percentage is a measurement of how much out of 100. So by definition, it's already a fraction. Put the percent. I'm trying to draw an O. It's not going well. There we are. Over 100. Okay? That's all there is to it. So because percentage is a measurement out of 100, this would be 35 out of 100, and this would be 75 out of 100 as well. And yes, they do reduce. So you can go ahead and do that if you want. 3/4. The instructions, it's a good habit to get into as you go through. Now one comes 7/20. Okay. Converting percent to a decimal, I'll use the same numbers. Just because I have that high degree of creativity, we'll just use the same numbers again. So simply, in order to convert the percent to a decimal, we simply divide the percent by 100. So divide the percent by 100. All right, that's it. So you physically just take that 35% divided by 100, and you get 0.35. 75 divided by 100, 0.75. That's it. All right. Converting decimals to percent. So let's go back to 0.35. Again, high degree of creativity here. I'll use the same numbers. So because, if we go back to the previous one, percent to a decimal, I had you, or the instruction was divide by 100. I know everyone's waiting at the edge of their seat for the final answer here, but it is multiply by 100. So multiply by 100. I know everyone is absolutely shocked by that outcome. So if you have a decimal and you're going to convert it to a percent, multiply it by 100, and you get your 35 and 75%. Now, converting fractions to percent, this is the ultra difficult, ultra hard questions. Let's go 2/5 and 1/10 because I like to do easy fractions that I can do in my head. Step 1, it's multi-step, and that's why it's very, very hard. So step 1 is divide the fraction. I know everyone's saying that is virtually impossible on a good day, but it is possible. Take out your calculator and you do 2 divided by 5 equals. Then multiply by 100. So 2 ultra complex steps that are virtually impossible to the average person, but I have ultimate faith in you. So you go through and you do your division. So 2 divided by 5 is, on the calculator, you'll get 0.4. I'll do it in multiple steps here because it is complicated. So that's step 1, divide the fraction. Now multiply it by 100, and you get your 40%. All right, so I'll do this one in slow motion, the 1/10. So divide the fraction, so here we go. 1 divided by 10 is 0.1. Now we multiply by 100 and get 10%. And there we are. Slow motion. Helped everyone out, I'm sure. All right, so there we go. It is now converted from fractions to percent. So those are all the only simple operations I want you to be able to do. I want you to be able to do those simple conversions, and that's it at this point in time. We are going to deal with this further, but that's they get a little bit more complicated, and that's what the grade 9 material or lessons will teach you and lead you on to. The final one's multiplying and dividing integers, and I'm more worried about the signs again. So it's like the adding and subtracting integers from the earlier part of the lesson. So what happens when we have -2 times -4, -2 times +4? What happens when we have +2 times -4? And what happens when we have +2 times +4? Just as a side note, some of the indicators for multiplication, if I use some old handouts, which does happen from time to time, it could be a dot. So this is the one you're most used to. Textbooks don't like using it very often because people get the x. When we start into the algebra, it looks like 2x4 instead of 2 times 4. So side-by-side brackets also indicate multiplication. And if you go to the real old books, so you go to college, some of the old professors will use the dot, and the dot is an indicator of multiplication. And they did that because back in the old days, before even computers, back with typewriters, the dot was an easy keyboard key to use to indicate multiplication. So there are a variety of forms. So these ones all indicate multiplication. The division, same thing. We'll take care of that in a second. If we have -2 times -4, negative times a negative, and that's what I'm most interested in. What happens when we multiply 2 negatives? Well, this is probably the only time that this statement is true, but 2 wrongs make a right. So negative times negative, the result would be +8. Okay? -2 times +4, 1 wrong, makes the whole thing wrong. So -8 makes it negative, doesn't make it wrong. 2 times -4, -8. Positive times a positive is +8. Same rules apply for division. So if I have -4 divided by -2, negative divided by negative will be +2. If I have +4 divided by -2, you would get -2. I'm showing you the different forms for the division that you might come across. If you have -4 divided by -2, oops, +2, should have switched the sign, you get -2. And I'm going to sign, so I got to go back to positive 4 divided by positive 2. Okay, so the same thing applies here. And the nice thing with the math here is that it lines up with the double signs with the adding and subtracting. So in general, if you have a negative multiplying a negative, results a positive. Positive times a negative is a negative. Negative times a positive is a negative. And positive times positive is positive. All right, so there you are. Those, like I said, it's nice those two rules line up. It makes things a little bit easier to remember and so on and so forth. So that will let you blast through package number 2. Like I said, you go at the pace that you're comfortable with. If you have questions about a specific topic, this is the perfect time to get my assistance one-on-one. The better you know this stuff now, the easier the grade 9 material becomes.